We'll proceed in summation to integral. Okay, summation to integral. We will see many things probably in the statistics, probability, artificial intelligence, and those scenarios where summation, repeated summation, identifying the problem, and then dividing the problem into many parts, calculating the solution of each part, and then add it. Okay, it looks very simple, but there are 2 points that is identified as crucial points here. One point, what is the one point? Like we say that uh, kind of one is the one point is the kind of the okay generic point. One point is the generic point. What is generic point? Generic point is like okay. Okay, so one is generic point. What is generic point? If I divide my problem into many sections, if I divide my problem into many sections, like we have identified dividing the problem into many sections. Dividing the problem into many sections means if this is the problem, what is the problem? We have talked about it many times. What is the problem? Problem is to find the circumference of a circle. If there is a circle, how to find circumference of the circle? I divide this circle into n number of parts. This is x-axis. This is x-axis. This is y-axis. This is x-axis. This is y-axis. I divide the circumference of circle into n number of parts. Okay. Now I calculate the length of each part and then I add it. Okay, then each part, if I divide this circumference into n number of parts, m number of parts, not necessarily that all n number of parts are of equal length, not required. This is what generally people think, that if I'm dividing my problem, then I have to divide the problem into equal number of parts, equal number of length. If I'm dividing this circle into n different parts, not required that each part is of length, same length. If I consider that each part is of same length, then if this is 2 pi angle, the length of one part is 2 pi by n. Okay, 2 pi by n. I'm sorry, if I said that this is the angle, that this, it takes an angle, right? This angle is 2 pi. If this angle is 2 pi, then length of the angle of any part, if I divide into equal number of parts, if I divide it into equal number of parts, then length of each part, the angle it forms, right? If this is the part and it forms an angle with the origin, what is the length, what is the delta of this angle? What is the size of that angle? If the angle is 2 pi, that is the full angle, it is divided into n number of chops, then angle equal n number of chops, then angle of any part is 2 pi by n. If it is not divided into equal n number of chops, there can be chance that it is not divided into equal n number of chops. Then what is the length of the angle of the ith section? So if this is the case, then this is the first section. This is x-axis, then this is the first section. This is second section. This is third section. This is ith section. Every angle is not same, not required. It will be same. But one thing is for sure. If if I have section number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to n sections are there. If I add angle of all the sections, if I add angle of all the sections, then it will come as 2 pi. That is for sure. What is the length of the angle of the ith section? That I call it delta theta I as subscript, bottom right, I as subscript, delta theta I, delta theta I is the angle of the ith section. If that is the angle of the ith section, then if I do summation I equal to 1 to n, delta theta I, it will be 2 pi. Okay, what is problem now? Problem is that I have to find circumference of the circle. Then I have to find circumference of the circle, circumference of the ith section of the cut. This is the arc of the length of this arc. So what is circumference of the circle? Summation I equal to 1 to n, and then circumference of the ith section or perimeter of the ith section. Capital P, bottom right I. Summation I equal to 1 to n, capital P, bottom right I, parameter of the ith section. Not required that all the section parameter are same because angle is not same. Still, this will hold true. What is the length of the parameter of the circle? That is P1 plus P2 plus P3 plus P4 plus Pn. What is the length of the ith section? Pi. What is the length of the parameter? Then summation I equal to 1 to n Pi. Okay, finding Pi is a big deal. This is what we are talking. Finding Pi as a generic fundamental, because this we will use as a generic concept, and that we will kind of make it available. We will generalize for the 1 to n. Finding Pi. Okay, Pi. If I say that I want to calculate the volume of a, I want to calculate the volume. Okay, if I say I want to calculate the volume of a sphere, this is a sphere, this is a sphere. I want to calculate volume of a sphere. Then a sphere has three axes, x-axis, y-axis, and z-axis. I have to chop x-axis into n part, y-axis into n part, and z-axis into n part. Now there are n to the power 3 number of volumes are there. If I address the n part of the x-axis, ith part, y-axis jth part, and z-axis kth part, then volume, small volume of any point here, there are n to the power 3 number of volumes are here. The I, j, and kth volume, the small volume inside this sphere, I, j, and k, the small volume inside this sphere. If I talk about it, then volume of the sphere is summation I equal to 1 to n, summation j equal to 1 to n, summation sigma sign k equal to 1 to n, and then volume of I, j, and k. Volume of I, j, and k section that we have to identify in a manner that I can expand it or generalize it for 1 to n to the power 3 section. There are n 1 to n to the power 3 sub volumes are there. Okay, that is the one challenge that comes into the picture. The next challenge that comes into the picture is once we write the ith, jth, kth section in 3D, ith, jth, and section in 2D, and ith section in the 1D. If I write like that, then write the summation fundamental, then converting, transforming, transitioning it to integral calculus is the big deal. Why we need to transfer it to integral calculus is when n tends to infinity, the number of sections we are making. If it is infinity, infinity means 10,000, no. 1 lakh means 100,000, no. Then 10 lakh, 1 million, no. Infinite. If I cut x-axis in infinite section and y-axis in infinite section and z-axis in infinite section, one volume will be infinitesimally small. If I add the volume of one volume and all the volume, it will be volume of this sphere. It is very lightweight though. There is no water here. So it will be volume of a sphere. Okay, when it takes when it becomes infinity, when it becomes infinity, then I have to convert into integral calculus. First, finding the ith, jth, and kth formula is tedious. Generic formula is tedious. Second, this is the first thing. Second tedious thing is then converting the summation into integral calculus. Anyway, okay, we will proceed with the calculating the volume of a cylinder. This is what we are engrossed into. Okay, we are okay. We are in phase of calculating volume of a cylinder, and there we are using lot of mind here. Means here we are investing lot of mind. Now, what is the volume of a sphere? Okay, in calculating the volume of a sphere, then we did from many fundamentals. We did from directly. What is directly? Now, to calculate the volume of a cylinder, then I found that we are calculating it through cylindrical coordinate system, pure cylindrical coordinate system. What is cylindrical coordinate system? If this is a cylinder and it is kept at xy plane, and this is the top circle, this is the bottom circle, and they are same. This is the surface of the curved surface of a cylinder. There are three length manner, there are three components in cylindrical coordinate system. One component is the arc, which is guided by angle called theta. Makes sense? If this is the top circle, then there is a radius, and radius moves like this, which forms an angle theta, and angle theta can be represented in length manner as the arc, where radius itself is a length, and then height. These are the three components in the cylindrical coordinate system. If I take any point P here, then from center it is a distance of r. Okay, if this I say this is x-axis, then point P can be little bit rotated, and this is point P here down. It is at angle. This is x-axis. If I say it moved, radius moved this much, and this is the angle we are talking. Now point P is down here. It moved angle theta. In that fashion, it moved the arc distance, that is r into theta. Okay, so any point P on the cylinder is r theta, comma, the height from here, that is z. Z goes from 0 to h, that is height of the cylinder, and theta goes from 0 to 2 pi, full angle, where radius goes from 0 to a. Consider A is the full radius of the circle. R is instantaneous radius. Instantaneous radius means I can take R from here to here, midway. I believe another will be better. Consider R I take from here to here. Okay, I believe both are of same size, exactly same size. Okay, consider this radius is A. This is full A. If I say this radius, this is A. Okay, if I take any instantaneous radius, middle from 0 to A, somewhere in between, radius R, and if I take this R, and then I move angle theta here, R, and move angle theta, and little down, this is the height Z. At that point is R comma R theta comma Z. Anyway, the radius is not like this. Radius is not like this. Radius is flat in xy plane only. Like in a sphere, we saw radius is anywhere. We saw radius as anywhere. Here, radius is flat. Theta is flat angle, and height is like this. Okay, in that fashion, we saw that the kind of I'm sorry. Then we saw that the we cut. I'm sorry. Okay, so now we have three components: radius, arc, and height. Radius we chopped into n number of parts. Arc, arc that is full 2 pi angle, arc we chopped into n number of parts, and height we chopped into n number of parts. Then there are n to the power 3 number of volume sections got created inside the cylinder. N to the power 3, because we cut radius into n, and then this arc into n, and this height into n. There are n to the power 3, n to the power 3 number of volume, small volume got generated inside the cylindrical volume. If I say that, if I represent radius from, if I have made n section, if I made n sections of the in radius, then I take ith section. Okay, along the circle, if I have chopped into n different parts, then I take the jth section, and along z I have chopped into n number of parts, I take kth section. I am talking about a point, a volume, sub volume inside this cylinder that belongs to ith, jth and kth section. What is the volume of ith, jth, kth section? That is V and subscript V, bottom right, I, J and K. Volume of the ith, jth and kth section. Okay, means summation sign, sigma sign I equal to 1 to n, sigma sign j equal to 1 to n, sigma sign k equal to 1 to n. Volume of ith, jth and kth section, that volume. If I add for all the I, J and K, I get the complete volume of cylinder. Today we will see in calculation of this volume that is purely into length vector fundamental. Length vector is a vector that we have invented. There is no concept of length vector in book. Anyone can see. There is nothing called length vector in the book. What is length vector? Length vector, if we see length vector, then length vector is a vector that represent a curved line. Why we are talking about length vector, that we will see. Length vector is a vector that is an algebraic vector. What is algebraic vector? 2, 2i plus 3j. This is not algebraic vector. This is called numerical vector. That is a straight line. If this is x-axis, this is y-axis, this is z-axis, 2i plus 3j would be something like this. It is a straight line that is crossing, that is starting from point 0 comma 0 and crossing a point 2 comma 3, 2i plus 3j. This is a straight line. Can we represent a curved line through vector? That is a question mark. We have talked about this in detail in the video series of length vector. I believe that is length vector. Length vector is a very big thing. If someone understands length vector, he can crack anything in the world. Length vector is very, very big thing. And the concept behind length vector is even bigger. Okay, how to find length vector? Length vector means, can I represent a line through vector? What is your line? My line is y equal to 2x. What? Y equal to 2x. That is my line. Means if this is x-axis and this is y-axis, if this is x-axis, this is y-axis, or this is y-axis, then y equal to 2x. There will be line like this, not at 45 degree, more than 45 degree. This will be the line, that is y equal to 2x. Okay, this line is passing through a point called 2 comma 4. Y equal to 2x. Every x has double y. It is passing through a point called 2 comma 4. Can someone tell me that what is the length on the line from 0 comma 0 to 2 comma 4? Makes sense? If there is a line called y equal to 2x, what is the length of the line section from 0 comma 0 to 2 comma 4? Or in other way, I would say, can someone represent the line into a vector? What is your line? Line equal to y equal to 2x. Y equal to 2x. Let's take any point on y equal to 2x line, and that point is x comma y. From origin, if I take the position vector of x comma y, this is y equal to 2x. I take any point here as x comma y. From origin, If I draw a straight line up to x comma y, this position vector will be xi plus yj. Then length will be x square plus y square square root. So representation of y equal to 2x is xi plus yj. Someone would say, but then it is xi plus yj for everything. Now substitute y for 2x. What is y? Y is 2x. It becomes xi plus 2xj. Okay. What about if x equal to 2? Then it is 2i plus 4j. If it is 2i plus 4j, it can be I plus 2j, certain. I plus 2j and 2i plus 4j are the same vector. Magnitude is different, but direction is same. Okay, as vector is energy source which has a magnitude and direction. Okay, if I say I have to find a length of a line section in y equal to 2x from 0 comma 0 to 2 comma 4. Then I have found the vector equation of this line is xi plus 2xj. 2 comma 4 means 2i plus 4j. The magnitude of 2i plus 4j is 2 square plus 4 square root. Means if I can represent any straight line as yi plus xi plus yj. Any straight line xi plus yj. Okay, thank you very much. Okay, I have another line that is a curved line, that is not a straight line. That is what we are saying. I have a curved line. What is a curved line? Curved line equation is y equal to x square. This is x axis and this is y equal to x square. Now tell me vector representation of this. Take any point here y x comma y. If it is x comma y, then draw a vector. Then from origin, if I take, then vector will go directly to the x comma y. If this point is x comma y, vector will go directly to x comma y. If I represent this as a vector, then I'll say xi plus yj, where y equal to x square. So xi plus x square j. Is it the vector representation? Is it the vector representation of a curved line? Y equal to yj plus x square. Y, I'm sorry, xi plus x square j. If I take any point here, vector representation of a curved line. Okay, okay. If I say vector representation of a curved line, then this point is x comma y, and line I draw from here to here is a straight line. It will go like this and hit this point x comma y. What is vector representation of this? This is xi plus yj, where y equal to x square. Xi plus x square j. That is the vector representation of any line. Well, that is position vector. This is what you said in position vector here also. If this is the curved line y equal to 2x, then this is okay. This is your luck that position vector is also the tangential vector. Means if I take a straight line and represent it through vector, vector will go along the straight line, exactly along the straight line. So we say that position vector or is the nothing but it is through position vector I can say it is a representation in vector form. Okay, in that fashion, if I have a line that is a curved line, if I have a line that is a curved line, and you have point x comma y, and if I say that can you represent this curved line through x comma y, then if I draw say it is also x comma xi comma yj, then it will be a straight line from origin touching x comma y and it will pass through it. That is xi plus yj. From here it will pass through this. That is the vector representation of a position vector that is going from not the what you want. I want a vector that will touch line and it will do like then it is a variable vector. It is not one vector I can represent your line because line is like this. Here the vector will be along the line will be like this. Here vector will be along the line. Everywhere vector is changing. It is only possible when vector is in representation of algebra. Then it is possible. Okay. Means changing x will keep changing the vector. Okay. Then it is possible. Otherwise, if this point is x comma y means any point like 4 comma 16. If it is 4 comma 16, then if I draw a line like this, then it will come as 4i plus 16j. In simplest form, it will come as I plus 4j. Anything will be beyond it only. I plus 4j, 2I plus 8j, 3I plus 12j, 4I plus 16j, like that. But that is not the line we are talking. We want line along the curve. That is called line length vector. Length vector, line vector, whatever it is. How to calculate that? Then we invented. Then we saw that if I have a xi plus yj as the vector representation of position vector, okay, if I had a straight line instead connecting 0 comma 0 to x comma y, then xi plus yj is the vector representation of this line. But if it is a curve, then what is the difference? Difference is that if it is a straight line, then y by x everywhere is a constant and same. Whereas if it is a curved line, then y by x, y by x, y by x, everywhere it is different. And it is more or less function of x at different x, y by x is different. Means whenever I try to represent a vector form of a curved line, y by x should be there because it is variable. Variable must be handled when we go for generic formula. That's it. What is generic formula? Generic formula is a formula where all variables are present there. Okay, so y by x should be there. So if I say my vector is xi plus yj, position vector, then take out x. That is the independent component anyway. X-axis, y-axis, x is independent component and y is dependent component. Y equal to x square means y is dependent upon x. In that fashion, if I take a length vector, if I take a position vector from origin to any point x comma y, then it is xi plus yj. Take out x to make it y. I want y by x somehow because that is variable. Take out x, it becomes x into in bracket I plus y by xj. X into I plus y by xj. Now it is the representation of a curved line because y by x is there, that is variable. Okay, division turns into differentiation and multiplication turns into integral calculus. Integral calculus is nothing but a graphical way of calculating the multiplication only. That's and differentiation is nothing but a graphical way to calculate the division only, nothing more than that. So we have now I plus dy by dx j bracket close into dx. This is called length vector. So can we calculate volume of a cylinder through length vector? That is question mark. And if I talk about the cylinder, if I cut radius into n section and then arc into n section and height into n section. Now if I take a small volume, now consider this is the radius. Consider this is the radius. This is the radius of the cylinder. If this is the radius of the cylinder, then at any moment, radius of the cylinder what we are talking is bigger. This is A. At any moment, this is R. Full A, or if this is A, this is the full radius of the cylinder. I cut into N part. I am at ith part and distance is R. Makes sense? This R distance is nothing but if this full distance is A, then every section distance is the length of every section is A by N. The ith section, if I am talking that this length is I into A by N, that is R. From R I have a circle. That again I have chopped into N part. I am talking about the jth part in the circle. What is that? Anyway, now the question is arising, what is the length vector of this? If I talk about the I, j and kth volume, that is the ith part in the radius, and in circumference, if I cut then jth part and height kth part. If I cut full h height into n section, I, j and kth part of the volume. If that is the case, then what is the volume? Volume, we talk that volume of any entity is triple dot product. Triple dot product is called volume of any entity. What is triple dot product? Cross product of two vectors. Whatever it comes, it will bring another vector. If I have three vectors, if I have a surface if I have a surface that can be nomenclated, that can be represented through three vectors. If I have a surface that can be represented through three vectors, tell me how this how if I have a volume, and that can be represented through three vectors. Tell me, if I have a volume here that I created by cutting the radius, cut, this is radius, then cutting into n part and one particular part in the radius I took. If this radius is flat, and then this arc cutting into n part, one part I took. I have demonstrated it earlier. Then in that fashion, this will come as a section in the area in the circle. If I take a cylinder, consider this is the top of the cylinder, that is a circle, and this is the radius. Okay. Now if I tilt it, this is the radius. Okay, this is A, full A of the circle, radius. Now I chop this into n part. I take this part, and this is the radius. This part, and this is the radius. Now, if I say that, consider ith part I am talking, that is the last point in the radius. Radius ith point is the last point, where here it is the jth part is here. This is the jth part that I cut. This is the jth part. Okay, if I talk about radius, then this is the arc that is going on. If I taken this section of the radius, then there will be another arc like this, cut from here to here, here to here, here to here, here to here. This is called ith jth section of the circle. Now, if I do like this, because circle is flat, then if I come down, then kth section in z, that small region will be the volume we are talking about. If that is the case, then what this volume, the ith, jth, kth volume is described by what three vectors? One vector is radius vector, or if this is delta r, then delta r vector. One line is this, another line is this, and another line is this. Our volume is confined by three vectors. One is radius vector, one is arc vector, that is round, and one is straight line vector, that is z vector. If I do triple dot product, okay, then I'll get the volume of the I, j and k section. What is the net volume of cylinder? Is I equal to 1 to n, summation j equal to 1 to n, summation k equal to 1 to n. Volume of the ith, jth, I, j, k section, where I have cut cylinder radius into n part, arc into n part, and height into n part. Ith, jth, k, which is boundary, which has a boundary with one vector as one vector, that is a flat, one vector at delta r vector, one is the arc vector, not theta vector, arc vector, and one is the height vector. If I talk about the length vector fundamental, we are talking where we have any point at xi plus yj plus zk, I take out independent components, and then whatever comes, then we change into algebra, into calculus form, and that is called length vector. If I talk about the radius, just watch it carefully. If I talk about the radius, if I talk about the radius, if I talk about the radius, then this is delta r of the ith section. If I talk about the arc, then this is the x-axis. Okay, in that fashion, we are talking about the jth section. R in ith section, this is jth section. This is the how I now what is the volume? This r vector, or if I say delta r is the subsection, delta r vector, and this is the subsection, that is the arc vector cross product. This will give the area vector cross product, dot product with the delta z vector. Okay, now how to represent this as a, if I see this radius, if I go along the radius, then nothing is changing. If I go along the radius, then only radius is changing, angle is still constant, and height is constant. When I move along radius, if I move along radius in cylindrical coordinate system, then only radius is changing, angle is constant, and height is constant. So now, what is the, now if I trying to find the length vector along the radius, means this is radius, what is length vector of it? If this is point 0, then, and this point is any point, what is your any point? Any point is r, any point is r comma r theta comma z. Uh, this is the coordinate system in cylindrical coordinate system. If I talk in vector form, this is r unit vector plus r theta unit vector plus z k unit vector. I'll take out independent component here, that is r, because r is varying, keeping theta and z as constant. If I take out r, it becomes r by r unit vector plus r theta by r theta unit vector plus as per the coordinates plus z by r k unit vector. Now I change it into calculus. It will become dr by dr r unit vector 1, that is r unit vector plus r d theta by dr. Theta is not changing, 0. Dz by dr 0. That is it. And outside we have r, that will become delta r. So it becomes delta r unit vector. Makes sense? Similarly, if I try to find the vector representation of this arc, because we are trying to calculate the volume. Volume is triple dot product, means cross product of, if I have a volume section, find three vectors of the volume. If I have this volume, then height vector and radius vector are straight, but arc vector is is not a straight line. That I have, so I have decided to go with the length vector of all three. For radius, for the ith section, length vector is delta r ith section r unit vector. Length vector of the arc for the jth section, if I see, then again I'll go with the how to calculate length vector. If I talk about the position vector, then the position vector in cylindrical coordinate system is r unit vector plus r theta unit vector plus z k unit vector. What is independent here? If I move along arc, then radius is constant, mind it. And if I move along arc, then z is constant. Anyway, I'll take out theta here because theta is variable here. In that fashion, because if I'm moving along arc, theta is varying. Now it becomes theta comes out and it becomes r by theta r unit vector plus r theta by theta unit vector plus z by theta k unit vector. If I change into calculus, it will become dr by d theta r unit vector plus r d theta by d theta theta unit vector plus dz by d theta k unit vector, bracket close, into delta theta. Theta will become delta theta. Dr by d theta 0, dz by d theta 0, and here it will remain as r theta unit vector. Now we have cross product of delta r of ith section r unit vector cross product r r r. Delta r is how much distance from the origin, delta r. This is 0 to a and ith section is r. Okay, we have talked about what is the distance. So r theta delta r of the ith section r unit vector cross product delta cross product r r up till ith section r, not delta r theta unit vector, because d theta by d theta is 1 plus dz by d theta 0. If I do the cross product of these two, then it will cross product of these two, bracket close, dot product of height vector. What is height vector? Again we will do the same thing. What is position vector in the cylindrical coordinate system? R unit vector, r theta unit vector plus z k unit vector. Here the variable is z. If I take about the height of a cylinder, if I go along like this, then neither theta is changing, not this is the r, nor r is changing, neither theta is changing, only z is changing. This is miraculous natural. In that fashion, if I take out z, it becomes r by z, r unit vector, plus r theta by z, theta unit vector, plus z by z, z unit vector. If I change into calculus, it will become dr by dz 0, r d theta by dz 0, dz by dz 1, k unit vector, bracket close, into delta z, dz. The z becomes dz. Now full expression is dr, delta r we are saying, now it is dr because we have changed it to calculus, dr. Now it becomes a dr. Okay, dr r unit vector cross product r theta unit vector, that will come as r dr k unit vector dot product k unit vector. It will come as scalar value. There won't be any vector at all. It will come as r dr d theta dz. That is the volume of the ith, jth, kth section. Now what is the volume if I say? Then summation I equal to 1 to n, summation j equal to 1 to n, summation k equal to 1 to n, or dr d theta dz, where dr or delta r belongs to is section, d theta or delta theta belongs to jth section, dz or delta z belongs to kth section. Now this I have to transform into integral calculus and then calculate the volume. This we have done already in the past section. Someone would say, I object here, because coordinate system what you have taken is not very famous one. That is r and then r, theta and z. The coordinate system that is famous in cylindrical coordinate system is xi plus yj plus zk. If we turn into r theta and z, then x is r cos theta, y is r sin theta, and z is z. So actual coordinate cylindrical coordinate system that is famous is r cos theta I plus r sin theta j plus zk. Okay, now can you show me like that? Okay, if I talk about the delta r, then I have to take out r here. I have to take out r here. Then it will become cos theta I plus sin theta j, okay, by r. Cos d cos theta by dr. I'm sorry. If I take out r, then it becomes r into in bracket cos theta by r I plus sin theta by r j plus z by r k. Okay, if I settle it as a calculus, then it will become now cos d cos theta by dr. Theta is not changing with the r if r is independent component. d cos theta, d cos d cos theta. I'm sorry. It is d. I'm really sorry. Okay, I'll try it again. Okay, it is r cos theta. I have r. I have taken out cos theta by d cos theta by dr, d sin theta by dr plus dz by dr. All are zero. So we cannot proceed like this. Let's try another way. Okay, what we have received through the kind of through our cylindrical coordinate system. Through cylindrical coordinate system we have received, if I going along r direction, then what I have got through the length vector fundamental. Length vector fundamental, what we have got is dr r unit vector, dr r unit vector, dr r unit vector. If we see dr r unit vector, then it is nothing but dp by dr. Am I right? dp by dr into or derivative of p, derivative of p, where theta and z is constant. If I say position vector, if I say position vector, what is your position vector? Position vector is xi plus yj plus zk. Position vector is r unit vector plus r theta unit vector plus z k unit vector. Position vector is r cos theta I plus r sin theta j plus zk. All are position vector only. But if I say this position vector in through cylindrical coordinate system, when r is changing and theta and z is variable, then this position vector becomes drr unit vector. This is what we have seen, a delta r unit vector. drr unit vector is nothing but d of position vector keeping theta and z as constant. This is what it is. Means I can rewrite what we have written now. What we have written now is dp, differentiation of position vector, cross differentiation of position vector multiplied by or dot product by differentiation of position vector. In first position vector r is variable. In second position vector theta is variable. In last position vector z is variable. In the dp, differentiation d small d and capital P, dp. Okay, if I take P as r cos theta I plus r sin theta j plus zk, then I have to substitute here again d of P cross d of P. First one, theta and z are constant, r is only variable. dp d of P, derivative of P with respect to r. It will become now, if I differentiate it, r cos theta, where r is variable, it will become cos theta I plus sin theta j, and differentiation of z with the r will be 0. Means z is, if I do dz, then it will be 0, because z is not changing here. Here r was there, so it made sense. So now it becomes cos theta I plus sin theta j, d of P. cross product d of p again where theta is variable and r and z are constant. So if I proceed like this, then it becomes r minus sine theta. R cos theta differentiation will be r minus sine theta. R minus sine theta I plus r cos theta j plus 0, because these z is not variable here. Now we do cross product of these two. Cos, I've never tried it though. I'm sorry, cos theta I plus sine theta j, cross product r minus sine theta I plus r cos theta j. Okay, if someone does the cross product, then I and j will make k. Then here I is cos theta and there it is r cos theta. It will become r cos square theta k. Okay, now I'll try another one. J cross product with the I. J cross J will be 0. J cross product I will be minus K. And here it is sine theta and here it is minus R sine theta. It will become R sine square theta K. More or less it becomes R cos square theta plus R sine square theta K. It will become R only. Make sense? R. Now let's settle down dp, that is the last one, differentiation of position vector where r and theta are constant, only z is variable. And there we have r cos theta I plus r sin theta j, r cos theta I plus r sin theta j plus zk. These are not available in any of the book. Now calculate d of p keeping z variable and other two constant. First two r and cos theta 0, r sin theta 0. Only it will become 1 into k vector. Now we have r k vector dot product with the r with k vector. It will become r only. So now we have now we have r. Means after all this, if I compute it, we have r. Okay, if we have r, then what is the end? So let's try again. This is the pseudocode I placed. Let's try again. Now we have d of p cross product d of p bracket close dot d of p. D of p I can rewrite as d of p by dr into dr. Makes sense. D of p I can write dp by d theta into d theta. Last d of p I can write as dp by dz. First dp by dr, theta and z is constant. R and z is constant. Theta and r is constant. So if I solve it, then first one dr numerator comes out, d theta numerator comes out, dz numerator comes out. So after this all calculation, dr d theta dz numerator will be there, and it is r dr d theta dz. It is with the typical Cartesian typical cylindrical coordinate system. Okay, r dr d theta dz. Anyway, d theta dz we can represent as delta ri is section, delta theta j section, delta z k section. Now the repeated summation what we are calculating is summation I equal to 1 to summation j equal to 1 to summation k equal to 1 to n. R. R is the radius of the top circle of a cylinder where full radius is a. R is the radius till ith section where there are n number of sections. Okay, R till ith section. Delta Ri, delta theta j, delta theta k. This is the full. Okay, please watch our previous video. Now this is called volume of the ith section. This volume, that is the generic volume, that is very difficult to compute. The generic volume of the ith, jth and kth section is R of the till ith section. Delta Ri, the width of the ith section. Delta theta j, width of the jth section, where it is divided into n parts. Delta zk, width of the kth section. Now summation of all three to this r I can consider as function over r theta and z, and delta theta, delta r and delta z I can write as delta r theta z. Now I have an axis called r theta z and there is a vertical axis called function over r theta and z. Now function over r theta and z is r here. Anyway, if this is the function over theta, there is a curved line, then function over theta, d function over, if there is a function, there is a x-axis. Instead of x-axis, we have an axis called r theta and z, only one axis, single axis, r, theta, and z. There is another axis called function over r, theta, and z, and there is a function that is the height at any point is function over r, theta, and z. If I calculate integration function over r, theta, z, d of r, theta, z, it will give area underneath it. This area underneath I can chop into many parts, and each area is sub area now, and sub area has a width. Now consider this area that is from begin to end limit f r theta z d r theta z. This area I chop into n to the power 3 times. I chop into n to the power 3 times, where each section length is delta r theta z. What is the area of this subsection? Function over r theta z into delta r theta z. If this section, if this section is I, j, and kth section, then function over r theta z of the I, j, and kth section and delta r theta r ith theta j and z kth section. This is the area of this subsection. If I add all the subsection area, it becomes full integration. This is a fit case to become full integration, or single summation someone can make it. Triple summation we have taken. Someone can write single summation. Alpha equal to lower end to higher end. Alpha equal to 1 to n to the power 3. N to the power 3 cut we have made. Function over r theta z and delta r theta z. Okay, for the alpha section. Make sense? Now it is 1 to the power 3. So yeah, I cut into n to the power 3 section. From begin to end, I cut into n to the power 3 section. And this is a particular section, and which width is delta theta z and r, and height is function over delta theta z, delta theta and z. If I multiply this height with this width, this is the area of this section. Add all the area, subsection area, it becomes function over theta r z, function over theta r z d theta r z, begin to end, not 0 to n to the power 3, whatever their limit is. Means more or less it will become, now this integration I can subdivide into 3 sections, since they are not varying with each other, they are not collinear. Radius is moving like this, angle is moving like this, and z is moving like this. They are not linear to each other, collinear to each other. They won't vary if you change something. Now we can limit it. Angle is 0 to 2 pi, radius is 0 to a, height is 0 to h, r d theta dz. It will come as r square by 2, r dr, a square by 2, dz 0 to h, 0 to h, and then v and angle is 0 to 2 pi. It will become pi r square h. That is the volume of cylinder. Someone would say it looks very interesting that just by calculating cross product and dot product we get the volume. Can you try? And biggest concept here is we are addressing the curve line through vector. That is the main thing. If you see in the book, then they will chop into n different parts and they will imagine the curve line is a straight line because angle is very small. That is difference from there and here. This is what it is mentioned in the book, that you chop everything into n parts, and if you chop a circle into n parts, and since one part is very small, I can consider that arc as a straight line. Here we are not considering arc as a straight line. Arc vector we are taking, that is variable, and it is really a arc vector. So if someone calculating the volume of a sphere, then there is r radius, and there is phi angle from vertical and theta angle from the horizontal. Okay, can someone calculate this volume through repeated summation and then arc vector? Arc vector means if I take theta arc, then it will be variable arc, variable vector. Not if I cut theta into like this, then one line I can take as a straight line, imagination. Because since angle is very small of each section, I can take the arc as a straight line. If I cut the phi into n section, phi angle arc into n section, then one section I consider the line is a straight line, because no, we are taking a curve line vector only. Through vector can represent a curve line. Vector means straight line, not required. Vector is not a straight line always. If it is a numeric vector, then it is a straight line. If it is an algebraic vector, then it can be set of vector, family of vector that will represent a curved line. That can be represented through the algebra. Algebra is family of point only. If I say sin x, there is nothing called sin x. It is a set of values, okay, where x is different. Similarly, if I represent a curved line through vector, there is set of vectors. Okay, each vector will, each new vector will come if I keep changing the algebraic value. That is algebraic vector. Through algebraic vector, can someone find the volume of a sphere? We will see it. One or two sessions we will take. Okay, we'll take other example. Mind-blowing, amazing, repeated summation through which we are calculating, and then arc length vector. We are calculating the volume of anything. Surface area of anything can be calculated error-free with the length vector. Please watch our previous videos on the length vector. That is mind-blowing, amazing. Please don't mind supporting us. It is not available in any of the books. +91 is the India country code, 9483160610 is the telephone number. +91 is the India country code, 9483160610 is the telephone number.